STYR is a new and intuitive way to experience driving.
Our ambition at STYR is to create a product that offers a novel experience in driving in video games. It would allow the user to intuitively control a real or virtual vehicle with the glove and pedal platform set. These are STYR's main components. The central Arduino Uno powers and collects data from the pedals and steering gloves. The accelerometer takes in Z-axis data to register left and right turns. The pedals have pressure sensors under them to register forward and backward motion. The breadboard here connects all the pieces together with a 5-volt input, ground wire, HC05 Bluetooth module, and resistors and series Bluetooth pressure sensors. This other circuit includes a slave Bluetooth module. This is connected to the Arduino Leonardo, which binds to the keyboard of the computer. STYR uses an accelerometer to detect turning and pressure sensor to detect forward and backward motion. We took tests to determine thresholds for left and right turns with the accelerometer, and resting, pressing, and hard pressing on the pressure sensor. These thresholds were then coded to Arduino and sent by Bluetooth to an Arduino Leonardo. The Leonardo has the capability to bind keyboard keys using Arduino keyboard functions. We ran into a challenge when the Bluetooth data from Arduino Uno wasn't sending to the Arduino Leonardo. We later found that Arduino Leonardo uses serial 1 functions instead of software serial to read Bluetooth data, and incorporated that into our code. Each reading from the accelerometer and pressure sensor was paired in all possible scenarios of omnidirectional motion and in combination with the nitro function in the video game that we selected.
When assembling the pedal apparatus for STYR, we strive to have the most streamlined control system as possible that felt like the real driving experience. Our initial idea was to have a pair of gloves and socks that can be worn by the user for maximum portability, but decided to create a pedal platform to have a more tactile response factor. We first wanted to set up the pedals with a push spring and have the full effect of a pedal going up and down, but due to the lack of springs available to us, we had to create a firm stand for the pedal to be placed upon. The pedals were also placed on a hinge originally to properly work with the spring system, but after we removed the springs, the hinges allowed us to work better on the pressure sensors below the pedals.
After we get the pedal assembly, we first laser cut the pedal assembly piece with the STYR logo on the end of the pedals. We then also created stands that put the pedals at the desired angles to retain true-to-life qualities, where in the real car, the gas pedal is lower at a lower angle than the brake pedal. We chose different heights. 3 sheets of 1/4 MDF were planted glued together to support the pedal. We used trigonometry to find the correct heights of the pedal supports. Lastly, we created square bases for the supports to rest on the pressure sensors. But after this first round of cutting, we found multiple issues. We didn't take into account the height of the hinge, making the supports too short because we wanted them to be specifically 4.5 inches for the hinge. We fixed this problem in the second round of cutting while also adding vector etching, which told the group where to put the pedals. After cutting everything out, we hot glued the pedal assembly while also tapping the holes with Arduino so that they could be screwed in. There were no problems this time in the cutting process, and the final assembly went very smooth.
Through this project, we learned how to incorporate many of the skills we encountered in lab into one project, including sending Bluetooth data, circuitry, laser cutting, Boolean logic, voltage dividers, and many other aspects of VSE. We learned patience and perseverance when our Bluetooth module wouldn't pair and when we had to wait a long time in line in RPO. For the future, STYR may be used as a convenient way to remotely drive any sort of electric vehicle, like a Halbot, remote-controlled toy car, or even an electric vehicle to run errands or drive a ride service.